Hi, welcome. This is a very, very quick summary of lesson 8. I'm not going to go into details, but I'll be focusing on how to optimize the area using the graphing calculator. Okay, so for those of you who are absent, here's what we're going to do. Okay, so we started off with the very first example where the perimeter is given at 24. Or a perimeter of 24 meters is given, and we're trying to maximize the area. So we constructed different rectangles of different sizes with the same perimeter. So 11 by 1, 10 by 2, 7 by 5, all have the same perimeter. And then we try to write a simplified expression for the length using the given perimeter, right? So, and then we wrote down L is equal to 12, take away W, all right? And as we calculated the area, given that the perimeter is the same, right, for different dimensions, that means different lengths and widths, we found out that the maximum area happens when the shape is a square. For our next example, what we did in class was instead of fixing the perimeter, we fixed the area and said, now given the area is 36 meters square, what is the minimum perimeter, right? And so we looked at different rectangles, right, all with the same area of 36. And then we tried to find out what different parameters will all those rectangles give. So we wrote an expression, a simplified expression for the length using the given area. So area is length times W. So area is given at 36. So L is 36 divided by W. So that we use that equation there to calculate the different values of length. Okay. So we can have a rectangle of 36 by 1. Okay. And area is 36. Or 18 by 2, and the area is still 36, but the perimeter would change from 74 to 40 if I just changed the length and the width, even though the area is the same, right? And then we found out that the minimum perimeter is for a square when the rectangle becomes a square, and the perimeter is and we get a minimum perimeter from 74 to 40 to 30 to 26 to 24.4 and then 24 and so on and so forth. Okay. Let me see if I can move this out of the way here. Okay, so that doesn't interfere. Right. Okay, so that was the second example. You can pause the video and watch, and you can try this out later, but I just kind of want to keep going, right? Because ultimately I want to do the graphing calculator skill. So the summary was rectangles with the same, so the overarching idea was that the rectangles with the same perimeter can have different areas, and a rectangle with maximum area for a given perimeter is a square. Rectangles with the same area can have different perimeters, and the rectangle with the minimum perimeter is a square, okay? So the rectangle with the minimum perimeter for a given area is a square. However, we have to be careful. What we have to be careful is this is valid if we only use all 4 sides for a perimeter, okay? So the next slide was a question right out of the Nelson textbook. And we have different rectangles here, all have the same perimeter of 64 units. The question is, which one has the greatest area? Even without calculating, we can say it's B because it's a square and it has the maximum area, even if the perimeter is the same for all the given rectangles, okay? And then the next one was what happens if I look at different 2D shapes, right? Here I have different 2D shapes, and we want to know which one has the least perimeter. It turns out that if a shape is approaching a circle, it will have the least perimeter, okay? So in this case, a triangle is farthest from a circle because it has only 3 corners. A square is closer to a circle because it has 4 corners. A pentagon is even more closer to a circle because it has 5 corners, and the one that begins to go more and more like a circle, or resemble a circle more, will have the least perimeter, and also the maximum area. Okay, so if I say all these shapes have the same area, which one has the least perimeter? It will be a circle. Or if I say, no, wait, I want to keep the perimeter the same, right? If I keep the perimeter same, the areas will be different. And then I compare the areas of all the shapes, the one with the maximum shape, sorry, the maximum area will be the one that is a circle or the one that's closest to a circle, right? So after the next one. Next question is, we did this question in class. We have, this question is a little different. Okay, here we cannot say, okay, it's going to be a square. I know it's going to be a square, so I'm going to take 18 meters and make it into a square. No, that doesn't work, okay? We cannot say it's going to be a 4x4 square. So what we're going to do is we are going to look at the parameter equation. P is equal to, the parameter is 18 meters. Okay, you can read the question. I don't want to spend too much time explaining this because the focus of today's lesson is graphing calculator skills, right? So parameter is given at 18 meters and the length, and it's used only for bordering 3 sides of the garden because on the 4th side there's a wall. Okay, so 2L plus W is the parameter. We want to maximize the area, right? Area is length times width. But we cannot write area in terms of 2 variables. We need to write area in terms of only 1 variable, right? So this is what we're going to do. We're taking area and writing it as length multiplied by width. And then, well, can I write it all in terms, area all in terms of length, or can I write area all in terms of width? Yes, it can be done. Okay, so we're going to look at the other equation and do that. So this is where we begin to use the graphing calculator. Okay, so I'm going to share screens with my graphing calculator now. Let's see. I should have a graphing calculator screen somewhere here. Probably this one. Yeah, there we go. Here we have a graphing calculator. Let me clear everything. Okay, I still have stuff from here. I go up. I press Control Delete to clear what's there, and then press Enter. Right? And then I also still have something here, Control, Delete, and then press Enter, okay? Okay, and then, okay, let's go back to the Tab key one more time. Control, Delete to clear, and then press Enter. Okay, everything is gone, okay? Also make sure that the screen is not adjusted, okay? I'm just going to put a standard screen, standard window, okay? Because that's what most likely you're going to have, right? Now, for graphing, okay, on the graphing calculator, you want to be on the scratch pad. You don't want to be under documents because then you'll have a lot of graphs and a lot of documents unless you want to save it. Okay, so we start with scratch pad graph. Okay, so scratch pad graph, and we go to graph. Okay, and okay, sorry, we go to graph, and then we want to enter the equation, so go to the Tab key, right? This is what our area equation is going to be. Okay, so our area equation was length multiplied by, you can go back and check your area equation. Okay, so let's look at the area equation again. Sorry, right, here's the second screen. The area equation was length times 18 minus 2L. Okay, so this is going to be your y value, L is going to be your x value. Okay, so we're going to go back and look at our graphing calculator now. Bear with me. Here we go. And instead of area, we have y value. Okay, so that's your y value. So instead of length, we have x. Okay, so I'm going to type here x. Okay, and then within bracket, I had 18 minus 2L. So I'm going to write 18 minus 2x instead of L. Okay, because y depends upon x. That's what this notation means, right? F is a function of x. That's a function notation. That basically means y depends upon x. So there should be x and that should be x, not L. Okay, otherwise it's not going to work. Make sure you press enter. Okay, oops. Oh, it doesn't accept an invalid input. Why is that? Because I didn't put a multiplication sign. So I have to go here and say, well, I have to put a multiplication sign. So I'm going to put a multiplication sign there, and then I'm going to press enter. All right, we got something very weird looking, right? It's because there's a graph that's kind of not completely visible. Now, length cannot be negative, but we can see the line is going into the negative axis, nor can area be negative. So we have area also going into the negative axis. And we want everything in the positive axis. So I'm going to go and set my window properly. So I'm going to menu, right? I'm going to window zoom. I'm not going to go zoom in and zoom out because that's somewhat useless, right? I'm going to go to manual window settings. Window settings. The X values are the lengths. Length cannot be minimum. I'm just going to use -1 because I still want to see the axis, okay? Maximum. Now the maximum length can be only 18 because you only have 18 meters of fencing, all right? So I'm just going to use 20 over here. Scale is auto. Y minimum, Y values are the area. Area cannot be negative. I'm just going to put -1 because I want to see the axis. Y maximum, what is the maximum area? If I had 18 by 1 rectangle, the area would already be 18, right? So probably let's just make it 50, okay? It could be less than 50, more than 50, but we can come back and adjust it. It's not the end of the world, okay? And then you just say, okay. All right, you have your graph here, okay? So I'm going to just click and drag this and put that away. If you don't know how to click and drag, I'll show you that in the class. Ask me later, right? So this is the Y value. X is the length, okay, 18 minus 12. So that's the maximum area. Okay, sorry, that's the area equation or the area graph. We want to find the maximum area. So pretty much we're trying to find where is the maximum. To find that, I'm going to use my graphing calculator to do that. I'm going to go to menu, right? Then I'm going to go to analyze graph, number 6. Right? And then I'm going to go to maximum. So I can go, I'm just going to press escape one more time to show this. Just go menu, then press number 6, and then press number 3, okay? So menu, 6, and 3, all right? Now you see a dotted line appear here, okay? And it says lower bound, okay? That means it's asking, the calculator is saying, well, where should I go look for the maximum? Because the calculator cannot see the maximum, okay? The calculator is waiting for you to tell it where to go do the calculation between what range of values it should calculate to find the maximum. So it's saying lower bound, where is the lower bound? So the lower bound should be set to the left of the maximum, okay? Because you're telling the calculator, hey, calculator, this is where I want you to go find the maximum between here and there. So that's the lower bound, okay? And then press enter. Now, the word lower bound, as you can see, has changed to the word upper bound. Then you just use your arrow keys and move to the right. Okay, so pretty much the shaded area is telling your calculator to do a bunch of calculations to find where the Y value is the maximum, what X value gives you the maximum Y value, okay? And then you press enter. Now you have your maximum, okay? That's 4.5 and 40.5. So that just tells you that when the length is 4.5 meters, right? When the length is 4.5 meters, the maximum area is 40.5, okay? So that is just basically the graphing calculator skills. Remember that for all optimization questions, optimizing area or perimeter or surface area or volume, the methodology is the same. What is the methodology? You always have to write whatever it is you're maximizing or minimizing in terms of just one variable. And how would you do that? You have to use the other equation, okay? So ultimately, this is the basics for all optimization questions in grade 9, which we're going to be doing, all right? You're going to be writing everything in terms of the area or the perimeter, whatever it is maximizing or minimizing, or the surface area or the volume. You have to write it in terms of one variable, put it into the graphing calculator, and figure out where the maximum is, okay? So that's all I have for you today, all right? Enjoy the rest of your day. Thank you.